Welcome to the B-Sides Hardware Hacking Village lab number 8. I'm Altbeer and I'm going to walk you through this lab, which is part of the presentation working with surface mount technology. So in this lab we're going to work with some surface mount components on the strip board that was provided in the Hardware Hacking Village kit. So let's take a look at what we got. So we have the same strip board that we've been using for all the other labs, and we're going to continue to use this strip board. You'll see at the bottom of the strip board, it has positions to put various types of surface mount components. We're going to be using the 1206 sized components. You should have received LEDs and resistors for that component type in the kit. So I've chosen a green resistor or a green LED, and then a 220 ohm resistor, and then we're going to need 3 pieces of wire. And what we're going to do is wire this up to the Arduino because it has spare digital ports that we haven't used in the other labs. The trinket is all used up as far as ports available, but it doesn't really matter. What we're focused on here is how to actually work with the components, and the microcontroller and its code, whether it's Arduino or CircuitPython, is less important at this point. So let's take a look at our presentation real quick. So what we're going to do is we're going to make a circuit. It's going to be a fairly simple circuit that just has a resistor and an LED, and it's going to get its signal, its power signal, from a pin off the Arduino and then return to ground. And then for the code, because the code is not what we're focused on here, we're just going to use a simple blink and LED code, very similar to the basic Arduino example code. And of course, all the code and everything else is available on the GitHub link, which is linked in to the Hardware Hacking Village website. Let's take a look at the schematic. Like I said, this is a simple one. We're going to come off of pin D1 off the Arduino. We're going to use a 220 ohm resistor. That's a 1206 sized resistor. We're going to use an LED. In my case, it's a green LED, but you should be able to choose between red and green because I believe those are the 2 colors I included in the kit. We're going to use a 1206. You can see the anode and the cathode, and then it returns to ground. So let's look at our physical layout. So what we're going to do is we're going to put the resistor and the LED next to each other here, because the way that I worked the connections on this strip board is I have the solder pads for surface mount components are connected via copper inside the PCB to through holes that are on either side of it. So we're going to use that to make a chain for our circuit. So we're going to start with the wire that is on N15, which this will be where pin D1 on the Arduino is. So N15, we're going to wire it through and bring it down here to H28. And then from there, we're going to wire the resistor in, not wire it. We're going to attach and solder the resistor in place between F and G, the F28 and G28. And then between these 2 through holes on the D row and the E row, we're going to put a little jumper wire there between D28 and E28. And then we're going to put our LED between the B28 pad and the C28 pad, and we're going to make sure that the anode is on C28 because that's where the positive voltage is coming in, and our cathode is heading to ground. And then to complete the circuit, we're going to connect a wire between A28 and the ground rail, the negative rail, VCC28. That will bring it back to ground because the Arduino is connected to that negative rail. So that's all there is to this. To show you the 2 different types of soldering that can be done with the surface mount components, we're going to do the LED with our traditional soldering method using a soldering iron and rosin core solder. And then for the resistor, we're going to use solder paste and a reflow soldering method using a hot air gun that I have. It's a rework tool that will use hot air on the component to heat up the solder paste to the point that it reflows. This way you can see how both methods work. And with components the size of the 1206, either of these methods should be viable. I'm just showing both methods so that you can see how they both work. All right, so with that, let us get to the soldering. Okay, so I'm going to start with the wires because those are going to use the traditional iron and they need to be heated up quite a bit, and I don't want to take a chance that I am going to damage my surface mount components by applying the extra heat needed to solder in these thick wires. So we will start with the N15 connection, which should be right in between two legs of the button that we put in on one of the previous labs. So that hole should be available. And then once we get it in there, I'm going to work the wire around through here. And we're going to want it to connect here, so I'm going to trim that end off. And we'll bend it down and put it in the appropriate hole, which is H28. Looks like that popped out a little. There we go. So I'm just bending those over so that they don't move out of the holes while I'm soldering. And then I'm going to solder all of these at once. So I'm going to work on putting the next wire in. Now this is just a small jumper wire, so I'm probably not going to need all of this wire here. In fact, let me trim some of that off. That's still a little too much. And then what I'm going to do is just hold the wire and slide the plastic. Sometimes that's easier with these really small cuts. All right, let's see if that's good enough. It's still a little wide. Okay. And that looks good. All right, and then the last wire that we're going to put in here is the one going to ground. Actually, let's take a look at this. So if I bend that there, then I only need to have that much plastic. And I have some extra wire too. Make sure that's going to work for us, and it looks like it will. All right, and you can see that with these wires in place, it creates the circuit, and we just need the two surface mount components to complete that circuit. So let's get this soldered up, and then we'll work on our surface mount components. Okay, let's see, I got that one, which went to that one. Ah, there's the one I missed. I knew my count was off. Okay, so those look like good solder joints. Let us cut the ends off, and then we will work on our surface mounts. All right, so for the surface mounts, you're going to notice that they're in this packaging. So the resistor is in this little paper package that has plastic over the top of it, and the LED is in a plastic package that has plastic over the top of it. When you get these components, they usually come in long strips. Like, I'll show you the resistor components. They come in these long strips with all the components on there. If you buy enough of them, they put them on a big reel for you because, let's see if I have a reel. I can't find one. But the reels are used to feed these into a like pick and place machine or some automation machine that is going to be used to put components down onto boards in an automated fashion. Since we're not doing that, we're working with components by hand. All we have to do is remove the components from these packagings. Now for this, I'm using a tweezer and a plier to hold on to it. And what I'm going to do is just hold the outside of the packaging with the plier, and you use two tweezers. I just find this easier. And then I'm going to rip the plastic off the top. But being gentle so that it doesn't bounce out of there. Because once this thing, these are small enough that if they end up on the floor, if you have carpeting, forget about ever seeing them again. They're gone forever. This one wants to be stubborn. There he is. So to give you an idea of just how small these are, and these 1206 components are fairly large for surface mount components. Yeah, I fit both of the components on my finger and they're really tiny. Now, for the resistor, it's not going to matter really which way we put it because this is a passive component. This one is polarized though. This is the LED, and I don't know if I can get this to focus. There you go. So the LED on the bottom has this green triangle. Now different LED manufacturers put different markings on their LEDs. This particular one uses that arrow or that triangle. And what that arrow is telling us is which way is the cathode. It's pointing at the cathode, so I know based on that it needs to go this way because that's the way the arrow is pointing, and I have my anode needs to be here and cathode there. So that's the way you read the LEDs, and like I said, there's different markings from the different manufacturers, but they all tend to point to the cathode. Alright, so we're going to start, since we're going to use the hot air gun with the resistor, we're going to put him aside for now, and we'll start with this LED. Now for the LED, I am going to use the traditional soldering method, meaning I'm going to use this iron and some rosin core solder. And the way that I'm going to do this is I'm going to put solder down on the pads that I'm eventually going to put the LED on. So we'll start just by heating up the pad, and then we'll add just a little bit of solder. You don't want too much. You don't want it to be a big lump of solder there. Just a tiny bit of solder on the pad like so. Because then we're going to take the LED component, and I'll make sure again it's going the right direction, and I'm going to hold it here on top of the pad while I heat it up from the side to melt that solder. And this takes some effort. And it looks like it's got good contact, but I can't tell if this side's melted down, so I'm just going to add a little more solder in there. I just put it on the tip of the iron to make sure it's got good contact on that side. I'm pretty sure this side has good contact. Alright, so that's our LED. It's soldered on there. Now what we're going to do is the resistor next. But one thing you can do with an LED, we're going to give it a second to cool down. If you want to test it, you can use a multimeter to test the connections through it. And I'll show you how to do that. And actually, if you're using an ohm meter is going to put a slight amount of voltage through the circuit. And so I put it on an ohm meter here. I think you can see that. And we can just test our connectivity. So I'm going to first hit this pin and then this one. And we see our ohm meter. Is that working? All right. So for example, if I was to hit both ends of this wire, yeah, there it goes. It shows that there's almost no ohms because that's just a chunk of wire. And then if I go from this wire to that pad, I can't get past the plastic on the wire. It's the same thing. So what we're going to want to do is find a contact point where I'm not touching plastic. And yeah, you see how we're showing an open right now. So that's telling me that this is actually, even though it looks good, it's not fully soldered on there. So we're going to apply a little more heat and try that again. And a lot of times it's a trial and error when you're dealing with surface mount components like this. So let's give this another quick try. Just take a quick inspection. And it could be that it's too far forward for it to make contact, but we'll give that another quick measurement. Yep, so we're going to have to trial and error this for just a second. Get this out of my way. And see if I can see. All right, try this once more. Push it up a little. And I don't want to heat it too long because these surface mount components do have a lower tolerance for heat. All right, that looks good. What I did was I pushed it up off the pad just a little bit so that I can make sure it was getting contacts on the pad. Because the pad is wide enough, it only needs to contact on like half the pad there. So I did push it up a little bit, and now I can see it has good contact. And we'll confirm that with our multimeter. And even though it's not lighting it up, I am showing that it is looking good. So that leaves... Oh, and I guess one more thing you could do to check, if you wanted to test it before you got all the components in, you could always use a battery and make sure that you're wiring it in correctly. So we know that positive is going to come from this side and negative is going there, so we can wire around the circuit with the battery. But I have no resistor here, so I'm going to want to just touch this very quickly. I don't want to burn out the LED. But yeah, we can see that from there to there it's working. All right, so now we got to get our resistor on there. That way it'll complete our circuit. And so we have our resistor. This is a 220 ohm resistor. And the way that we're going to put this one on, and I can see now I'm going to have an issue with the plastic from this wire getting in my way. I'm just going to trim back this plastic a little bit because we're going to be using a hot air soldering technique, and this plastic is just going to melt. I probably should have done this before I put the wires in, so note to self or note to you, if you're using hot air soldering, it's going to get the whole area around here hot. So you might want to have plastic covered wires done after the hot air soldering, but we'll see just how badly this works. All right, so we got our resistor, and what we're going to use is this material called solder paste. So solder paste is like a powdered solder mixed with flux, and this allows it to be applied as a paste instead of in the solid form that we're used to. And this paste is going to be sticky, and there it is. And it's going to have certain temperature requirements. So based on which one you have, you can tell the ramp up temp. So this is when you get it warm and when it gets to peak. And so I'm going to have to emulate this by hand with the hand soldering tool, where I'm going to slowly bring the heat up by getting it closer to the object. And hopefully this will turn out okay on camera. So with this solder paste, a little goes a long way. So we really don't want a lot of it on the board. And whoop, that's too much. Let me get a paper towel. And so if you can see, I put just a little dab on each, and even that is a little too much. So I'm going to wipe off about half of that amount. If you have too much on there, it has the possibility of bridging the contact. So I'm just using this to scrape away some. Alright, and then we're going to place our component. So we know it's a 220 ohm component because it says 221 on there. And we're going to place it down on there and just kind of push it down into the paste. And then I'm going to fire up this tool, which is the heat gun, and it is set for right now 250 degrees Celsius. So I'm going to try to do this in such a way that the camera can still see the component, but it doesn't blow it away. Normally, when I'm using the heat gun, I try to come directly perpendicular down on top of the component so that you don't have air pushing it to the side. In this case, for you to see what's going on the camera, I have to hold it kind of to the side. So you can see I'm getting closer as I want it to get hotter, and I'm going to have to use my tweezers to hold this in place because otherwise it's going to blow to the side. And it's starting to bubble up, so we can see it solidifying, and eventually all that flux evaporates, and what we're left with is molten solder. So we'll just give it a second, and that looks like all the flux is gone now. And so I'm going to pull that back. And we want to scrape away any of the flux or solder, and this is still wet, so you want to be careful that you don't jostle the components too much while they're still cooling. But I did want to scrape away that little piece that looked like it could possibly bridge the connection. Okay, and so that resistor looks good. Yep. So we'll give that a few more minutes to harden, and then when we come back, we will give this another test, and we will use our Arduino to test the code. Okay, this looks good, and I just tested it with a multimeter, and it tested out good. A little blurry there. Alright, so what we're going to do next is we're going to use a safety tester to plug in the Arduino, and I think this Arduino might already have the code, the blink code on there, because I was playing with this earlier, but we'll find out. Yep, and we can see it's blinking the code. So just to clarify what code it is we're looking at, let me show you the diagram, or the code example. So this is just a simple blink. I called it LAB08. I'm defining it on pin 1. I define it as an output pin, and then I make it go high and then low, and with a ½ delay. So simple code, just there to test out our circuit. And as far as the NeoPixel being blue, that's its normal color when it's not receiving a signal. So let me see if I can get this a little closer and focus in so you can see it. And there is our working circuit. So we were able to work with one of the components via the traditional soldering method, and we worked with the other one using the reflow solder method. So you can see the difference between the two by looking at the components. You can see the reflow is much cleaner than the traditional, but the traditional works. So in a pinch, it'll work for you. All right, so let us go back to our presentation real quick. So yeah, what we worked with, just to go back here, this was the flat chip type. And if you remember, I showed you the LED was in kind of an arrow shape pointing at the cathode. This could have been a plus shape or just a line. That tells you which side of the LED is the cathode. And then the number, we had a resistor that was 221. So that tells us 2, 2, and then the position 1 is 1, 0. So that means it's 220 ohms. So that's how we know our resistor is the right value. And then we built our circuit with those and got it to blink for us. And that is the end of this lab. I did include in the Hardware Hacking Village kit several other components that are surface mount components. So you'll have different sized LEDs, the 1206, the 805, and I think I even included a 603 in there. That you can work with. And the strip board here has connections for all of those. So if you wanted to play further with those, you'll have resistors and LEDs that you can play with and get used to soldering them in whatever soldering method that you want to use. This presentation was available on altbeer.us/SMT. And here is the GitHub where you'll find the code and the schematic and any other information about all of the labs. With that, we're at the end of the BSides labs. So thank you very much for attending, and I hope you enjoy the rest of your BSidesDFW con. Thanks.